You said never let me go. You said never let me go.
Hello viewers, welcome to Tiema Home Lesson channel. This is a place where chemistry is made easy for your understanding. We run the WAEC and IGCSE syllabuses that will help prepare you for WAEC, NECO and UTME examination in Nigeria and the International General Certificate of Secondary Education Examination for candidates that want to study abroad. Our lessons are structured based on our scheme to capture the three grades of learners, which are grade 10, 11, and 12, or SS1, 2, and 3, respectively. Welcome back. Today we are going to look at the remaining parts of week 2 topic. The remaining part of first term week 2 topic of SS1 scheme. And the topic is isotopy, relative atomic mass, and relative molecular mass. Isotopy, relative atomic mass, and relative molecular mass. However, if you have not yet watched our previous videos of week 1 and 2 lessons, I would advise that you watch those videos so that you'll be able to understand this lesson. We have 4 videos already, so check the description box of this video. You will see the links to those videos. Watch them and then come back and watch this one so that you'll be able to understand this topic. Thank you very much as you comply. All right. Welcome back. Isotopy, relative atomic mass, and relative molecular mass. What are they? What is isotopy? Isotopy in chemistry refers to the situation where by 2 or more atoms of the same chemical element have the same number of protons in their nuclei but different number of neutrons. It is a situation whereby 2 or more atoms of the same element have the same number of protons in their nuclei but different number of neutrons. And these different atoms are called isotopes. Let's take, for example, carbon. Carbon as an element has 3 different kinds of atoms, 3 different kinds of isotopes, which are carbon 12, carbon 13, and carbon 14. The atomic number of carbon is 6. Atomic number means the number of protons in the nucleus of an atom. Now, these 3 different atoms of carbon or isotopes of carbon all have 6 protons in their nuclei. They differ in the number of neutrons, which are 6, 7, and 8 respectively. That is, for instance, carbon 12 has 6 protons and 6 neutrons. Carbon 13 has 6 protons and 7 neutrons, while carbon 14 has 6 protons and 8 neutrons. So what makes the difference between them? Is that they have different number of neutrons in their nucleus. Now, isotopes. What are isotopes? What are isotopes? We define isotopes as atoms of the same element which have the same number of protons but differ in the number of neutrons. Isotopes are atoms of the same element which have the same number of protons but differ in the number of neutrons. Or we can also define isotopes as atoms of the same element which have the same atomic number but different mass numbers. Atoms of the same element which have the same atomic number but different mass numbers. Now, atomic number means the number of protons in the nucleus. And then mass number is the sum of protons and neutrons in the nucleus. Now let's see the properties of isotopes. Properties of isotopes. Isotopes have the same number of protons, they have the same number of electrons, they have the same electron configuration. arrangement of electrons in their shells. They have the same chemical properties. They have different mass numbers, and they have different number of neutrons. Properties of isotopes: they have the same number of protons or atomic number. They have the same number of electrons. They have the same electron configuration or arrangement of electrons in their shells. They have the same chemical properties. They have different mass numbers. They have different number of neutrons in their nuclei. Now let's see types of isotopes. There are two types of isotopes. We have stable isotopes and radioactive isotopes. Stable isotopes, these are isotopes that do not undergo radioactive decay. Radioactive isotopes are those isotopes that undergo radioactive decay. Examples of stable isotopes are carbon 12, carbon 13, oxygen 16, and oxygen 17. While examples of radioactive isotopes are iodine 131, carbon 14, and uranium 238. Iodine 131, carbon 14, and uranium 238. All right. Now let's see relative atomic mass. Relative atomic mass. The relative atomic mass of an element is the weighted average mass of one atom of the element on a scale where a carbon 12 atom weighs exactly 12 units. The relative atomic mass of an element is the weighted average mass of one atom of that element on a scale where carbon 12 weighs exactly 12 units. Now, carbon 12 is used as a standard atom for comparing the masses of other atoms for some of these reasons. The first is availability, and then the second is stability. Availability: carbon 12 is more abundant than most other isotopes. Then stability: carbon 12 is more stable than many other isotopes. It doesn't undergo radioactive decay. Now let's see how to calculate relative atomic mass. Example: what is the relative atomic mass of chlorine if a sample of chlorine gas contains chlorine 35 in 75% abundance and chlorine 37 in 25% abundance? Solution: mass fraction of chlorine 35 is 75% times 35. That is 75 over 100 times 35, which is equal to 26.25. And mass fraction of chlorine 37 is 25% of 37. That is 25 over 100 times 37, which is 9.25. Now, the relative atomic mass of chlorine is the summation of those two mass fractions. That is 26.25 plus 9.25, which is equal to 35.5. Now, note that the relative atomic mass of an element does not have a unit. Also, note that the relative atomic mass of most elements are decimal numbers because of the phenomenon of isotopy. All right, now, relative molecular mass. This is the average mass of one molecule of a substance on a scale where a carbon 12 atom weighs exactly 12 units. Let's take, for example, calculate the relative molecular mass of hydrogen tetraoxosulfate 6, H2SO4, given that the relative atomic mass of hydrogen is 1, that of sulfur is 32, and that of oxygen is 16. Solution: H2SO4 equals to 1 times 2 plus 32 times 1 plus 16 times 4. And that is equal to 98. So 98 is the relative molecular mass of hydrogen tetraoxosulfate 6. Thank you very much for being part of today's lesson. I hope you enjoyed the lesson. I have this little assignment for you. Thank you very much as you attempt those questions to assess yourself of your level of understanding of this lesson. Do have a wonderful day. Bye bye.